second video now deals with the Poisson distribution. So let's go ahead and click on the worksheet tab that says Poisson. Again, a quick recap. Poisson distribution. This is where our random variable x counts the number of events that occur at random in a continuous interval of time or space. Then our x has a Poisson random variable. The average number of events that occur in a time, space, or interval is denoted by mu. So there's two bits of information that you should look for in a question. Firstly, are they stipulating the average number of events? So look for mean, look for average. Secondly, look to see if they are now defining the random variable in some interval of time or space. The Poisson function or the Excel function to calculate Poisson probabilities would be equal to Poisson.dist. And here again, we start off with x, where x specifies the value of the random variable. There's only one parameter for the Poisson distribution, and that being mu, and true false works exactly the same way. You're going to use true if you're trying to find a cumulative probability, but it must be in this form here, probability of x less than equal to some small x, and you will use false if you want to calculate an exact probability. So let's look at an example. Cars arrive at a BP petrol station at an average rate of 12 cars per hour. So immediately, here's the word average rate, and it is giving you some interval here of time. So you've got 12 cars per hour. What is the probability that 8 cars arrive in the next hour? Now again, when you are defining your random variable, define it as per the question. The question is asking you for the number of cars or the probability of 8 cars that arrive in the next hour. Okay, so we're looking at an hour interval. So let's define x to be the number of cars that arrive per hour. Now, the question has given us the average rate based on an hour rate. So x has a Poisson distribution. There's our average 12, where mu now is our parameter. And the question, being an exact probability, is what they want you to find, probability that x is equal to 8. If you used your PMF, this is what you would get. But if we wanted to type this into Excel, again, we're going to use insert function. And now let's type in Poisson, got the S, double S, and say go. So it's given me Poisson.dist. I say okay. What is my x value? It's 8. What is my mu? My mu is my parameter, which is 12. And then it's asking me, is this cumulative or is it not cumulative? Because it is an exact probability, I'm going to type in false. And then, okay, this is my answer. Easy, simple, follow the instructions in the insert function. So now, what is the probability that 3 cars arrive in 10 minutes? I've underlined this. Why? Because remember, when we defined our random variable x, we defined it per hour, which means that we now need to adjust our mu value, our average. What were we given? Mu was equal to 12 per hour. And now we have 10 minutes. But we know that an hour is equivalent to 60 minutes. So how do we calculate our new mu? It's going to be the 12 out of 60 times now the new 10 minutes that we are looking at. And this gives us a new mu value or a new parameter of 2. So what is the probability that 3 cars? This again is an exact probability. X equal to 3. So let's again insert function. Poisson is here. Let's say, okay, our x now is probability that 3 cars. Let's type in 3. Okay. Our mean is the new mean, which is 2, and we're going to type in false. And that gives us a value of 0.1804. Oops, there should be 3. Let's just adjust that while we are here. Probability that x is equal to 3. All right, so proceeding now. What is the probability that at most 23 cars arrive in 2 hours? They've changed the time interval again. So let's do exactly what we did. We have been given mu to be equal to 12 per hour, which means that we want to now find the equivalence for 2 hours. So 12 cars in 1 hour times, we now have 2 hours, so that's going to give me 24. So the question is asking us to find the probability that at most 23. 23 must be the most number, the highest. Hence, we are looking at the probability of x less than equal to 23. Cumulative, good. Less than equal to, yes. So now it means that I can use my Poisson function. So here again, insert function, Poisson is already activated. What is the probability that at most 23? Okay, so we're going to type in 23. And what is our new mean, which is 24? And since this is cumulative, we're going to say true. Okay. Oops, again, this has not been adjusted. So there's 23, and let's adjust that. So this is now the probability that we have calculated. The last one. What is the probability that more than 14 cars arrive in 1.5 hours? They've changed the interval yet again. So you should be quite comfortable now doing this. 12 cars per hour, that means 12 in every hour, but now we're adjusting it to 1.5 hours, giving us a new mu value of 18. Cumulative, again, more than 14, greater than 14, we cannot use the Excel function as it stands. This needs to be adjusted. So x greater than 14 is the same as the probability of x greater than equal to 15, or 1 minus the probability of x less than equal to 14. Now all we have to do is, again, use insert function. So Poisson, yes. And again, our x value is going to be 14. Our new mu value is going to be 18. And because this is cumulative, I'm going to say true. But remember, we want 1 minus. So let's go to our formula bar and insert a 1 minus. Press enter, and this now gives us the probability that we are interested in.